Okay, so the title looks kind of funny, whatever. Let's take the equation y equals x squared minus 6x plus 5. And let's find a vertex in a different way. So there's a formula for the vertex in the title and all over the notes. Negative b over 2a, comma, whatever y is. There's a formula for y. It's in the notes, whatever. So we're going to substitute in this formula. So on the left-hand side, the b value is b equals negative 6. So we're going to substitute negative 6 in for b. Now that's negative 6. And the a value in front, a is just equal to 1, so we can put 1 in for a. And it's just comma y, whatever. And we can simplify that. Negative 6 is positive 6. 2 times 1 is 2, comma y, which is 3, comma y. Brackets around it. Circle your answer. Now, instead of having some complicated formula for y, like c minus b squared over 4a, whatever, in the notes. And remember, we just already completed the square a couple of sections ago. Haha, this looks messy. Where we used the formula 3 times big blue, b over 2 all squared, b over 2 all squared, b over 2 all squared. So this new formula, minus b over 2a, is similar, but not exactly. So we got to memorize enough stuff. So don't memorize some formula for y. Just know that you can make a table of values and put the 3 value for x that we just figured out and figure out what y is. Rewriting the equation from above and carefully taking the x value 3 and putting it in for x. Y equals 3 squared minus 6, 3 plus 5. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is negative 9. Plus 5 is negative 4. Circle my answer. And then we know that the vertex is our x value 3 and our y value negative 4. Circle your answer twice. Finding the vertex using the formula negative b over 2a. Or, look, do all the substitutions of all the values in the table and just make a table and figure out what the vertex is by the bottom point. Either way, let's draw this graph. 3, negative 4 is there. Can you see that? Excuse me. Sorry about that. So, can you see that? Yes, you can. So, let's put that point on the graph. 3, negative 4, the vertex. Now we knew from before a was 1, so we can do our 1, 1 pattern. So 1 squared is 1, 2 squared is 4, and again 1 squared is 1, and 2 squared is 4, and whatever. Let's look at this. 3 squared is 9. Whoa. Table of values in your head. Now, what if we only got the x values? So what if I only got the x value, the x-intercept of, excuse me, 1, 0, and 5, 0. Well, look at that. Cutting it in half with the axis of symmetry is at 3. Well, how can we get 3 from these numbers? Well, we can calculate the average by adding up the x values and dividing them by 2. 5 plus 1 is 6, divided by 2 is 3. Getting the equation in big red of the axis of symmetry, x equals 3. The axis of symmetry, finding the symmetrical point. Then you know that the x value is 3, and you can just put it into a table. So you can be given the equation, and you can change the vertex form, or you can just use the formula minus b over 2a like we did above. Or if you're given the graph from down below, where all you're given was these two x-intercepts and they didn't actually draw the graph for you, well, then you can average the two x values. You'll figure out the x value. That is the x value of the vertex. And then put it into the table to find the y value. Then you'll know the y value. Then do your 1 squared is 1, 2 squared is 4 pattern. And then whatever. Find the vertex from the average. Okay, so that's vertex form. Next chapter, we're going to take a look much more into standard form, finding x-intercepts.